What would happen if an animal never went to sleep? Across the animal kingdom, shutting down is a near universal biological requirement. From mammals to birds to reptiles, the brain requires periods of unconscious rest to maintain itself and process information. This creates a persistent evolutionary trade-off. To obtain the benefits of rest, an animal must enter a state of unconsciousness, ignoring its surroundings and remaining defenseless against predators. Because this downtime is so dangerous, finding a single creature that manages to bypass it forces us to look closer at how and if all brains actually need to shut down. That search leads to the stagnant waters of the swamp to look at a specific suspect, the North American bullfrog. Like all amphibians, bullfrogs are cold-blooded. They regulate their internal temperature using their environment, a process that relies on absolute physical stillness to conserve energy. Because they blend into the mud and remain motionless for hours, they give off the visual impression that they spend the majority of their lives fast asleep. To confirm this, researchers decided to empirically test the bullfrog's resting state. They expected to map out a standard cycle of deep sleep, but the data returned an unexpected result. The numbers suggested that the bullfrog's internal systems might be capable of running continuously without the need for a traditional shutdown. Documenting sleep in a bullfrog is difficult. They rarely close their eyes, and their bodies are already motionless, so visual observation isn't enough to determine when they are truly resting. Instead, scientists used physical stimuli. They applied a mild, harmless physical shock to the bullfrogs at specific intervals, testing their responses during the brightest parts of the day and the darkest hours of the night. This graph shows the baseline for an awake animal. Feeling a stimulus, its nervous system triggers an almost instantaneous physical reaction. But for a sleeping animal, that response is delayed. The brain requires measurable time to transition and signal the muscles. Biologists rely on this specific gap in reaction speed to identify sleep. If there is no delay in response, the animal is categorized as biologically awake. The researchers administered these tests on the bullfrogs during their deepest nocturnal resting phases, the hours when the swamp is pitch black and standard biological clocks would trigger a deep sleep. This scatter plot shows the bullfrog's reaction data. Instead of the expected nocturnal delay, response time stayed the same, forming a flat horizontal trend line. Whether resting or active, the numerical data was identical. There was no measurable variance. This means the bullfrog's nervous system remains primed to fire at a moment's notice. Even after sitting in the dark for hours, its brain detects and reacts to physical stimuli without any measurable transition from a sleep state. By the standards of this specific measurement, the data failed to detect any period where the bullfrog was biologically asleep. Does this mean bullfrogs simply don't need rest? The answer lies in separating physical rest from cognitive sleep. Bullfrogs do lower their metabolic rate and conserve energy by staying still, but they appear to do so without ever disengaging their awareness. Biologists describe this as perpetual vigilance. The animal shuts down physical movement to save energy, yet keeps its sensory processing centers active to monitor the swamp for predators. To survive in an environment where threats emerge from the water or the sky without warning, the bullfrog avoids the vulnerability of a deep sleep cycle in favor of an always-on neural state. Our understanding of sleep is often centered on how mammalian biology operates, assuming that because our brains require a total shutdown, all brains must follow the same pattern. The bullfrog shows that biological recovery can take different forms. This amphibian sits motionless, but its brain remains alert, challenging our assumptions about the limits of the nervous system. Even with all of our modern testing, the natural world still hides complex biological mysteries right in plain sight. If you want to explore more of these natural anomalies, subscribe and ring the bell to catch every episode of The Explainer. Let us know in the comments which weird animal mystery we should investigate next.